Good day, everyone. I'm Lee Yansun from George Brown College. Today, I will be presenting a technical proposal of our group that works with Ms. Wong and Mr. Cheung on reducing border crossing congestions and wait times on Gordie Howe International Bridge by integrating new technology, such as 5G connectivity, smart mobilities, and data analytics. To achieve the goal, our proposal is divided into two main directions. The first one is reducing the wait time at customs and immigrations, and the second one is reducing traffic congestion on the bridge and connected roads. First, let's focus on the first one. The average time vehicle spends on the payment and security checks takes about 3 to 5 minutes, which is a significant burden during peak hours. To address the issue, we will utilize 5G technologies and with integration of software and hardware, such as smartphone cameras and sensors. Before arriving to the border, user will create an account using their email address and verify it through the applications. They can complete their traveler profile by scanning their travel documents like passports, their smartphone cameras. Optical character recognitions will convert the image into machine readable text, and the data will be transmitted to database. The driver will upload biometrics, create vehicle profile by inputting the license plate number and answering general inquiries. Toll payment can be made through the online sections here too. Let's look into the components on the diagram and let's see how they will have to match and how it works. The car will first arrive at the booth. The camera will start capture and select the clearest license plate image to transmit to the database for OCR processing. The system will return with travelers' identities and pre-upload vehicle informations. RFID scanners can also scan license plate if driver equipped RFID tags and use as a redundancy plan to pull weather or unclear tests. Driver and passengers have to interact with 4 authentication stations to provide biometric verifications. At the same time, thermal sensor and low-power X-rays will investigate the car to check the goods and count the number of people going through. If everything matches, the gate will open and the driver can continue through the booth. During the process, traveler may use video communication device to ask for help from the officers. If information unmatched happens, they will have to listen to the officers' instructions through video communications. If the stop bar will not release with vehicles, and driver will be instructed by traffic lights to further investigations. Let's get on the bridge and start traveling. The proposed solution in this part is aimed at to address the traffic congestion by utilizing dynamic capacity adaptation approach. This part is proposed to allow lane direction change from the third and fourth lane of the bridge to adapt to the changing demand with capacity allocations. High traffic are monitored to predict future demands in each lane and change direction if needed. This dynamic approach will help adjust the traffic if accident happens on the bridge that block the lanes. To implement this approach, various end devices such as radio-enabled cameras, sensors, message boards, and V2X-enabled vehicle will be used. They will collect and send data such as vehicle status, traffic occupied rate, and video capture traffic to related MEC for processing. MEC will handle authentication and security, data processing, and virtual mapping. It will gather real-time traffic information and communicate with corresponding end device and V2X-enabled vehicles to provide mapping service. MEC will also deliver control message to message boards and traffic lights for lane counterflow actions or lane switching actions and messaging actions. Real-time traffic monitoring and demand analysis will decide if there's a need to change lane directions. Overall, this proposal suggests using 5G and V2X communications to enable dynamic capacity adaptations, which could improve capacity allocations and reduce traffic congestions on the cross-border bridge. Thank you for your attention. This is the end of our presentation. Thank you.